Okay, so for 21, it says, what is the speed of the drag racer in number 15 at the end of the run? So what you want to do is go to number 15 and then gather some information here. So the first thing you want to gather, and I'm going to switch slides here. The first thing it says on number 15 is that the acceleration, so you would do A equals, so acceleration equals, sorry, wrong slide, 10 meters per second squared, or 10.0. Remember that 10.0 because the 0 is important. And then you have the distance, so the change in x equals 400 meters. 400 meters. And then you know how long it took for the car to travel this distance, so you could put that value down as well. Alright, so now I need to find the equation that I can use for an acceleration and change in distance, and then I need to find a final velocity. So another thing we know that I didn't write down here, so let me write it down. You also know the starting velocity, or the initial velocity, right? The initial velocity is 0 meters per second because the drag racer started its car from rest and then accelerates at 10 meters per second squared, the entire distance of 400 meters. So we know also the initial velocity. What we're trying to find out is the final velocity, because it's asking what is the final velocity in that question. So what is the final velocity? So let me switch slides here again, and we'll go back to the question, make sure we have all the information we need. So if I go to 21, it says, what is the speed of the drag racer at number 15 at the end of the run? So we have all of our information now. Now we need to find an equation. So I'm going to scroll down until I get to the equations tab on slide 14. And what I'm trying to do is find a final velocity. I have the initial velocity. I have I know I need the final velocity, and I know I have the acceleration and change in x. So what would I use? Well, I'd probably use this equation right here, because this gives me the final velocity. So I'm going to have to do some squaring here. I'm going to have to do some square rooting after I'm all done. So basically, initial velocity is going to be 0. Plug in your acceleration, which is 10 meters per second squared. Multiply that times the distance, which is 400, and then multiply all that by 2, and then you got to square root all that, and that should give you your final velocity. So that pretty much covers 21. So let me stop recording here, and I'll switch over to 22. Okay, so 22 says use a different equation to solve the problem. So if you're looking at question 14, you solved for time on that one. So I haven't put together my key yet, but you guys should have that time available to you. So you should know this number. So let me switch back to monitor 1. But you solved for time on question 15. So you should know this answer. I don't know what this is right here, but some answer here. You know that. So you have another value of time. So is there an equation where we don't use maybe the change in x, but instead we use time? So is there another equation we can use that uses time instead of change in x? So if you scroll down, so let me go back to my other monitor here. If you scroll down to the next slide, or if we go down to our equations, so let's go down to our equations here, and you're looking for one that uses time instead of change in x. So this is the one we used before. Can you find one that uses time, acceleration, initial velocity in order to find final velocity? So where would that be at? And you probably guessed it by now, but it's right here. So go ahead and use that equation with the time value that you found. See if your final velocities are the same. And that's just a way of we can verify those equations, see if they're working, see if that's how that works, see if these are valid equations. Okay, go ahead and do that. That's how you answer 22. Now 23 says if you were taking a test, which would be the better equation to use for 21 and 22? I don't know. I think you need to look at the equations and see which one you think would be easier to use. You might be able to come up with a little easier, might be able to come up with a little bit better. Check out your sig figs, see if there's more or less sig figs. That might be the answer, or it might help you with that answer. On September 24th, 2010, Aroldis Chapman set an MLB record when he threw a 105-mile-per-hour fastball against San Diego Padres. Let's assume the ball started from rest in his hand and left his hand at 105.1 miles per hour. So if his arm moved through 1 meter before releasing the ball at that speed, what acceleration did he give the ball? So it went from 0 to 105 miles per hour. You need to convert miles per hour in order to get that. So you have the distance, the change in x. So let me go back to my other slide here. Let me erase everything I have here. And then I'll go back to my other slide. So let me go back. Whoops, wrong color. Let me put it back to white. Okay. So you have a fastball thrown at, so you have your final velocity, right? Hold on. Final velocity equals 105.1 miles per hour. And you need to convert this to meters per second. So this is a conversion problem. Convert it to meters per second. So you know there are 60 minutes in an hour, and each minute has 60 seconds. So you got to convert that hour with the correct time value to seconds, and you have to convert miles to meters. And it tells you that there is 1,610 meters equals 1 mile. So you got to convert those. Convert this. And then after you convert that, you'll have the final velocity. And remember, the initial velocity equals 0 because it says his ball started from rest. And then the change in x, was 1 meter, right? Before releasing the ball at the 105 miles per hour. And then you want to find, it says, what is the acceleration? What is the acceleration? So what equation would you use there? So we have the acceleration. We're looking for the acceleration. We have a displacement. We have initial velocity and a final velocity. So how do we find acceleration? Well, if we go back to our slides, and you look down at our equations. So we have the acceleration. Or we don't have the acceleration, sorry. We don't have the acceleration, but we have our change in x, and we have our initial velocity and final velocity. So how do we find that acceleration? Well, we may want to rework this equation right here. So check out that equation, see if you can rework it. Hope this helps, and I'll see you in class.